Welcome to Le Podcast de Philippe.
Very cool.
We are diving into some pretty cool developments in European transportation today.
Okay.
Specifically, we're going to look at the Hyperloop project that's being spearheaded by the EPFL and its partners.
All right.
They recently had a very successful test where they simulated a significant journey at high speeds, and we're going to unpack all of that. We're going to talk about the test results, the technology behind it, particularly something called a linear induction motor.
Mm-hmm.
And we're also going to discuss the implications for the future of rapid and sustainable travel across Europe. And I think a lot of this information is going to correct some earlier figures that were maybe not quite accurate. So this is going to be exciting. I am very excited about this.
Interesting.
And just a quick aside, if you're enjoying these deep dives and you're watching us on YouTube, please subscribe to our channel. We're trying to reach 1,000 subscribers today. So,
all right, let's get into it. This Hyperloop test, tell me about it. What happened here?
well, what's really exciting about this particular test is the distance that they managed to simulate.
The consortium, which involves EPFL, HEIG-VD, and Swisspod Technologies, were able to replicate a journey of 141.6 kilometers.
Wow.
Which is roughly 88 miles.
Okay.
Now, this is a significant distance, and it wasn't just a short burst of speed. This was a sustained test that was carried out within their 11.8-kilometer test track, which is located at EPFL's Hyperloop Test Center. And during the simulated journey, they reached a top speed of 488.2 kilometers per hour.
Wow.
Which translates to just over 303 miles per hour.
That's incredible, especially within a test facility.
Yeah.
So tell me a little bit about this test center, because I understand that it has a rather unique design.
It does. It's a circular structure. It has a 40-centimeter diameter and 125.6-meter circumference.
Wow.
And it's specifically designed this way to allow for rapid prototyping and testing of different Hyperloop components and systems.
I see.
Now, what's fascinating about this test center is that the entire setup operates at a scale of 1.2, meaning that it represents a scaled-down version of a proposed full-size European Hyperloop system.
That's so clever.
So by conducting these tests at a smaller scale, they can gather crucial data on performance and validate their technological principles before having to actually invest in large-scale infrastructure, which would be much more expensive.
It's a really clever way to kind of test things out without having to go full scale right away.
Exactly.
So this aim, it extends beyond just sort of demonstrating speed, right?
Right.
They are looking at trying to create a more sustainable and efficient way to travel.
Exactly. This project is called Limitless.
Okay.
Which stands for Linear Induction Motor Drive for Traction and Levitation in Sustainable Hyperloop Systems.
Okay.
And their fundamental goal is to create a lightweight and highly efficient infrastructure for this type of rapid transit. And because it's more efficient inherently, that's going to lower operational costs and also contribute to its overall energy efficiency.
So that's really the aim here, is to really make something that is sustainable and efficient in the long term. Okay, so and this successful test that they've had, it really suggests that this could be a very viable option for high speed and environmentally conscious travel in the future.
Absolutely. I think this is a very promising step towards realizing that vision.
Yeah. I mean, for someone like me, this could dramatically change the way that I travel across Europe.
Absolutely.
So the linear induction motor, or LIM, this seems to be at the heart of all of this efficiency. So what is it about this technology that makes it so well suited for this particular application?
The LIM is really crucial to the Hyperloop's energy efficiency, and it all comes down to magnetic propulsion and levitation.
Okay.
So instead of using wheels or even air-based suspension like some other high-speed systems, the LIM uses magnetic fields to both propel the pod forward and lift it slightly above the track.
Interesting.
This essentially eliminates the energy losses that are caused by friction, which is a huge factor in conventional transportation systems.
Yeah.
In fact, studies have shown that up to 70% of a high-speed train's energy consumption is actually due to air resistance and wheel friction.
Wow.
So by using this magnetic levitation and propulsion system, the Hyperloop can bypass this huge energy drain.
That's a massive saving in energy right there.
Exactly.
And I recall reading that there was a very specific integration of functions within this motor that the Limitless project was able to achieve.
Right. So one of the most innovative aspects of the Limitless project is that they were able to successfully integrate both the magnetic levitation and the propulsion functions into a single limb.
Oh, wow.
So this unified design leads to very high energy conversion efficiency.
So it's essentially a much more direct and efficient transfer of power to motion.
Precisely.
And there's also this mechanism, I understand, for recovering energy during deceleration as well.
Right. So another benefit of using the limb is that it allows for what we call regenerative braking.
Okay.
So when the Hyperloop pod needs to slow down, the kinetic energy that it's built up isn't just lost as heat like it is in conventional braking systems.
Right. Instead, the limb can act as a generator.
Okay.
And this converts that kinetic energy back into electricity.
Oh, wow.
Which can then be stored and reused by the system.
That's incredible.
So essentially, the Hyperloop is able to reclaim energy that would otherwise be wasted. And this further boosts its overall energy efficiency.
So it's almost like a hybrid car, but operating at hundreds of miles per hour inside a vacuum tube.
It's a good analogy.
So speaking of the vacuum environment, the Hyperloop obviously operates within this near vacuum tube. So how does the limb perform in these kind of low pressure conditions?
Well, the limb is surprisingly well suited to the vacuum environment of the Hyperloop tube.
Okay.
You see, traditional propulsion systems often generate a lot of heat due to friction with the air and also from their mechanical components. But in a near vacuum dissipating, this heat becomes a real challenge.
Yeah.
However, because the limb is based on contactless magnetic forces, it inherently generates far less heat than those traditional systems.
This means that the problem of thermal management inside the Hyperloop tube is greatly simplified.
I see.
And that contributes to its overall energy efficiency and stability.
It sounds like it was practically tailor-made for this kind of operational environment.
It really does.
And what about control? So how well does the limb allow the operators to control the speed and the acceleration of the pod?
The limb offers really precise control over the pod's speed and acceleration.
Okay.
And this level of control allows the system to optimize energy consumption in real time.
Okay.
It can adjust the power output to precisely match the propulsion needs at any given moment.
So it avoids any unnecessary energy wastage.
Exactly. It avoids things like excessive acceleration or maintaining speeds that are higher than necessary. So you've got this intelligent system that essentially uses only the energy that's required for efficient and safe travel.
So just to kind of summarize here, it sounds like the linear induction motor is really fundamental to the Hyperloop's efficiency.
Yeah.
And this is because of several factors. It's contactless propulsion and levitation. It has this integrated functionality. It's able to regenerate braking energy. It's well suited to the vacuum environment. And it offers this really precise level of control.
Right.
So it seems like all of these advantages are really what make this project so promising for the future of rapid and sustainable transportation.
It's a convergence of technologies that really makes this very exciting.
Absolutely. This has been a really insightful deep dive into the European Hyperloop project. The success of this simulation, coupled with this innovative use of the linear induction motor, really demonstrates that this is much more than just a concept. It's a tangible step towards a potentially game-changing mode of transport for Europe.
Yeah, I think what's really important to take away here is that this successful simulation, even though it was at a reduced scale, provides really strong evidence that this technology could be viable for rapid travel across the continent.
Absolutely. And on that note, I'm going to leave our listeners with a final thought. Given the encouraging results of this 1.1 scale simulation, what do you think are going to be the most significant hurdles that engineers and policymakers are going to need to overcome in order to scale this up to a fully operational continent-wide transportation network? It's a pretty complex challenge to think about, but one that could have incredible implications for the future of travel. Thank you for joining us for this deep dive into the European Hyperloop project, and we'll see you next time.